Okay, so we're going to model the Vert, so I'm going to start a new part, and of course, as always, I'm going to start a standard millimeter.ipt. I'm going to be flicking through between Inventor, and I also have the PDF open of the drawings. It's sometimes easier, obviously, to print out your drawings so you're not flicking through, or have two screens. The first thing that we always do, of course, I'm going to create a 2D sketch. So, of course, the hotkey is S, or you can click up here in the tab. And it's then going to say, okay, you would like to create a sketch. Which plane would you like to choose? So I'm going to go on to the XZ plane, which is this one just here. And this is what we're trying to create here. So this is the cylinder, so the vertical cylinder of the elbow engine. So of course there are many ways of modelling this. I'm going to show you what I think is the most efficient. So first of all, we're going to go and draw the circle, and then we're going to extrude it to get the main body of the cylinder. So we can see that we need a 28mm diameter circle, and we'll be extruding by 24mm. So of course we're going to use the circle tool. The hotkey for that is C, and it always defaults to a center point circle, which is what we would like to use. So I'm going to go ahead and, of course, I'm snapping this to the origin, which is 0, 0, 0 on the XYZ. It's very important that you fully constrain your sketches, and it's also a good idea to always do it around the center. So of course you click to start the circle, and you can then see that it's going to do it by the diameter. So we know that that's 28mm, so I can type it in now, and it will add the dimension in for us. And you can see that geometry has gone blue, which means it is fully constrained. I'm going to escape out of the circle tool, and we can see down here on our status bar that this is now fully constrained. And Inventor is quite clever. You can hit any 3D modelling hotkey from this position. So for example, we're trying to extrude, so I could hit E now, but I'll show you the other way, which is I'll click Finish Sketch. It will then take us back into that 3D view, and then you then have your tool up here, which is Extrude. If I select the Extrude tool, this is basically a quick shortcut of what's in this box, but just for clarity I'm going to open the box just to show you. So of course there's only one profile in our 2D sketch geometry, so Inventor has cleverly picked that up and said this must be what you're trying to extrude. If it hasn't selected something, this profile up here will have a little red mouse cursor, and then you can manually select the profile. So the options available to us are distance, which will be determined by what you type in here. The other option is to. So if you had some 3D geometry in this IPT, you could select it and it would extrude to the part that you've selected. Or between, of course, you can select two pieces of 3D geometry, and it will go between the first one you select and the second one. We're going to extrude the distance, because we've given that, which is on here, which is 24mm, so we're going to put 24 in here. Now the other thing you can change with Inventor is the direction, so we can change it, and you can see it flip there in the preview, but we're going to do symmetric, so that the centre of gravity is on 0, 0, 0. So we're going to click OK, and of course all of these options here you can see are the same as in this box. So I'm going to hit OK. We've now got the basis of our vertical cylinder, so as you can see by the drawing, if I go to the isometric view, you can see we're already nearly there. It's a very simple piece, so we've just got to do 4 holes. So I'm going to use the hole tool to create the holes. So the first thing I'm going to do is I'll show you using the 3D hole tool, and I'll also show you it in combination with a 2D sketch. So the first thing we're going to do is the center through hole. When you select the hole tool, you're again given a very similar looking dialog box with your options. So the one I would like to do is a concentric hole, because I'm going to use the body of the cylinder as my concentric reference to do the through hole through the center. So if I select concentric, it says, okay, which plane am I going to start drilling this hole from? And you can see there's a blue box around, which means this is what I would now be selecting. I'm going to go into 3D space, and I'm going to select this top face here. And where you click your mouse is actually where it places the hole to start with. It then asks you for a concentric reference, so I'm going to use the main body of the cylinder, as discussed, where you can see it highlights in red on the preview. It's now placed that hole dead center using this as the concentric reference. So the only option we have here is the diameter, because the termination is through all. You can change this to distance, and you will then get a second box here which asks you for the depth. But of course, to make this model parametric, we want it to be through all, so that no matter what happens with the main body of the cylinder, this hole will always be through all. You have options down here to make it a clearance hole or a thread or a tapered thread. On the base plate you'll see the use of different tool functions, so you may want to check out the chronicle for the base plate to see these. So I'm going to hit OK, and that's going to put our 6mm through hole in using the so I'm just holding F4 now to help me orbit this around, so you can see, there you go, the hole has gone all the way through. The other way of using the hole tool is you can actually do it in combination with a sketch. So I'm going to press the hotkey S for sketch, and I'm going to start a new sketch on this top face just here. Now you've got points up here which they're always used if you want the point to be picked up in the 3D space. Go here and select a point. You can see I've now got this little crosshairs here, and I need 2 dimensions to fully constrain this, but of course we can use our constraints. So up here in my constraint panel, I'm going to use the vertical constraint to align this point with the center of my cylinder. And as you can see, this yellow geometry is projected, so if the center of this moves, the vertical alignment will also move. So you can see we now only need 1 dimension to constrain this, and of course it is the dimension in the Z direction. So I'm going to press D for the hotkey dimension, which is the tool up here, and I'm going to do a dimension from the point to the center point of the cylinder. And if we go back to our PDF, we can see that there is actually a diameter here with 3 equally spaced 6mm through holes, and you can see that it's got a PCD of 16mm because we have this radius dimension here of 8. So that's quite handy that it's the same as the dimension I've just added. So I'll change this to 8mm. You can now see just about that the point has changed to blue geometry, which means we are fully constrained as per down here. And again, like I said earlier, you can use the hotkeys from this position, so I'm going to do that, as we know the one for hole is H. And there you go, it's starting to put the hole in, and it's also remembered my selection options from last time. So we've got 6mm through all. As you can see, the placement here, rather than being concentric or linear on point, is saying from sketch, because it knows that if you've placed a point down, the chances are you want to use the hole tool. So as per the PDF, we need another 6mm through hole, 3 off 6mm, so I'm going to select OK. Now we could have put 3 points down, or we could have patterned the point in the 2D sketch geometry, but of course you do have the option to pattern features. So we're going to use the circular pattern. So if you select that tool, the first thing it asks you is, okay, which feature am I patterning? So we know it's the hole 2 because it's the one we've just created, so I'm going to select that in my browser. It's then going to say, okay, I also need a rotation axis because you're trying to do a circular pattern. So if I select this one, and you can use any of the concentric faces in here, so you can use the inner one, the outer one, or you can even go into your origin because we did it on the center line, and you can use the y-axis there. But I'm going to use this concentric reference here. So it's 6 occurrences within 360 degrees, and that also includes the feature that you are patterning. So we know we need 3 in total, equally spaced around 360 degrees, and as you can see the preview, it's shown here that we're going to get 2 more holes. So we're going to select OK. If we go down here, we can see that the material is brass. So I'm going to go back into Inventor. So we now need to add a material. So there's a couple of ways of doing this. You can right click on the part and then go into eye properties, or alternatively you can click on the application menu and then you've got eye properties there. It's the same, as you can see, it's the same tab. It's the part 1 eye properties. So if I quickly run through summary, so you can give things a title in here. So for example, this one is cylinder Vert, and you can add obviously all these items. So the author, put my name in there. Options in here like manager, company, and if you go through the project, file subtype modelling, the part number. So for example, this could have the name cylinder vert, but have the part number CV-001, and you can put a description in there. So this is the vertical cylinder for the elbow engine. Now all of these actually can be pulled through into your drawing template. We'll go through that later when we produce the drawing. Revision number, of course, you can put 1, 2, A, B, C. Project, world skills, regional example, designer. So the name and the designer is actually pulled straight from the operating system. So as this was originally under the name of Will, that's why that's pulled through automatically. I've just never updated the OS. But what we're actually interested in is the physical properties. So in here you have the inventor preloaded materials. So of course we're going to select brass. And again, if you hit apply, that will apply that to the model, and you'll see the preview change, and it leaves the box open so you can carry on editing. That's the completed part. If you press F6, it goes back to your home view, and of course F5 is previous view. So that's your vertical cylinder. So of course I'm going to save that, and because we set up that IPJ earlier, it's dropped me straight into the World Skills Regional Example folder. So I'm just going to call this cylinder vert. I'm going to hit save, and that will be that part completed.